a été difficile à organiser et nous sommes donc contents qu'elle ait lieu. Et j'espère qu'un certain nombre d'entreprises que nous avons mises en place, comme par exemple le site Chomsky.fr, où nous mettons à la disposition de tous certains textes qui ne sont plus publiés aujourd'hui, comme par exemple la linguistique cartésienne, vous aidera à en fait reprendre peut-être le lien de cette pensée linguistique qui est, de mon point de vue, c'est un point de vue personnel, aussi révolutionnaire que en fait le travail de Noam en linguistique, en politique, excusez-moi, qui évidemment est nécessaire aussi. Je passe immédiatement la parole à
Well, can you hear me? Is this working? Yeah. Yes? Can you hear me in the back? No? Yes? Okay. Yeah. I can't say, if you can't hear me, raise your hand. But well, it's hard to believe that this many people are interested in the status of labeling algorithms and the dubious character of specifiers and so on, which is what I wanted to talk about. But I'll start with some general comments and try to get to some more some issues that actually have been ignored in technical linguistic work, and when looked at, raise some very interesting questions. I'll try to say a couple of words about them to the extent that time allows. So just to start from a very general perspective, there are lots of different ways of investigating what's informally called language, but there's one that has a kind of logical priority in the sense that every approach presupposes its results, at least tacitly, even when that's hotly denied. That is the approach that considers the capacity for language of an individual person. We all have that capacity. The conclusions about that capacity arise tacitly, no matter what you're studying. Social interchange, using language, taking down a text from a tape recording or whatever it may be from an informant. You must make some assumptions, at least tacit, about the linguistic capacity of the person. Well, the direct study of the linguistic capacity of a person is the study of what's sometimes called internal language, whatever you have in your head, I language for short. So that concept, the study of I language, is somehow logically presupposed by everything. And if we investigate that topic, we enter into an inquiry into language as essentially part of biology. Whatever the linguistic capacity of a person is, it's something internal to us. It's essentially a kind of an organ of the body on a par with the visual system or the immune system or some other subsystems, sometimes called modules or organs of the body, subsystems of a more complex structure which have enough internal integrity so that they can be studied in abstraction from the rest, and then you can investigate their interactions with other modules, organs of the entire organism in its life. So I language is such a system. What is it? Well, its most elementary property is that it is the property of what's called discrete infinity. So take sentences. You can have a 5-word sentence, you can have a 6-word sentence, but you can't have a 5.5-word sentence. And it goes on indefinitely. You can have a 100-word sentence, a 10,000-word sentence, and so on. So it's like the numbers, the natural numbers. That property of discrete infinity is important, and it's from a biological point of view, it's quite unusual. You don't find it in the biological world. above the level of maybe DNA. But it seems to be a unique property of human language. You find it in the number system, but that's probably an offshoot of language. There's no other system in the world that's known to have that property. Well, the general theory of discrete infinity is pretty well understood. It has been well understood since the 1940s. It's called the theory of algorithms, theory of recursive functions, various other names. And the theory of language is going to fit in there somewhere. That is, the core of an I language is going to be some kind of an algorithm, some kind of a generative procedure that constructs an infinite array of hierarchically structured expressions, all internal to us, which are then transmitted to what are sometimes called interfaces to other systems of the cognitive system, physical system. And there are at least two of these. One is the sensory motor system, because it's externalized somehow. And the other is systems of thought, planning, understanding, perception, interpretation, loosely called the semantic interface. So there's a phonetic interface and a semantic interface. Phonetic interfaces with the sensory motor system, the semantic, pragmatic interfaces with systems of thought, planning, action, and so on. And the core properties of language are that it has such a generative system, that's the I language, which essentially provides instructions to these other systems. Now, we're interested in this generative procedure in what's technically called inintention, not extension. That's intention with an S, meaning we want to know what it actually is, not just what is the class of structures that it generates. So that's study of a function in intention, and that's what we're interested in if we want to consider language as part of the biological world, because what's represented in our brain somehow is a particular algorithm, not a class of algorithms which are equivalent in the sense that they have the same category of structures that they produce. So we're interested in, so I language is individual and intentional relation.
In this respect, it's the same as the study of any other module. We want to know how it actually works, not just the class of things it can produce. The approach to language in these terms began to take off in the early 1950s, and it's part of what's sometimes called the cognitive revolution, which actually in many ways was recapitulating a forgotten cognitive revolution that took place in the 17th and 18th century, and that was then sort of forgotten and reconstructed. So it ought to be called the second cognitive revolution in the 1950s. And the study of I language was a part of that. It helped stimulate it, it grew within it. If you study language in this way, it arose in sharp conflict with prevailing conceptions of how human thought and action should be investigated, and not just language, but everything. So the general framework of the time was what was called the behavioral sciences, behaviorism in psychology, in social science, and so on. And in linguistics, structuralist approaches, procedural approaches, methods of reducing a corpus to an organized form, and so on. That was the general conception of how language and behavior generally should be investigated. But this is a contrast. This is saying let's study it as part of biology, the way we study other biological systems, other modules of the mind, ultimately the structure of the brain. Well, if you investigate language this way, several questions arise immediately, the same ones that arise in the investigation of, say, the visual system. Roughly speaking, these are what, how, and why questions. So what are the properties of the systems of the individual I languages? Second, that's the what question. How are they acquired? So how does an infant acquire the language capacity that you and I are now using?
in its own particular way. And the why questions are, why does it work this way, not some other way? You can think of lots of ways in which it could happen. Why does it happen in this particular way? Those are the same kinds of questions you would ask, say, about the immune system or the visual system, and in fact are asked. Well, there are some reasonable guidelines as to how to approach these questions, guidelines that come from the very early stages of the modern scientific revolution. This is early science. We can learn a lot from the way early modern science developed. And there's some very striking features of what's often called the Galilean Revolution, the period from Galileo through Newton and beyond. One striking property of that early period was that scientists were willing to become puzzled about things that looked obvious. So for 2,000 years, it had been accepted that if an object, like say an apple, is detached from a tree, it'll fall down rather than go up. And it was taken for granted that if steam will go to the sky. So an apple will fall down and steam will go to the sky. And there was an answer for 2,000 years, the Aristotelian answer. They're going to their natural place. End of story. As long as they're going to their natural place, there's no science. Science begins when you allow yourself to be puzzled as to why they're going to their natural place. And these are the kind, and then of course you raise other questions, like was automatically assumed, it's pure common sense, that the rate of fall depends on mass. Well, if you begin to be puzzled, is it true? Why is it true? Well, it turns out it's not true. And Galileo gave an answer not on the basis of the fable about the leaning tower of Pisa, but he gave a thought experiment, pure thought experiment, from which it followed just conceptually that it can't be true. And it was very convincing. You didn't have to do an experiment. In fact, most of Galileo's experiments weren't actually conducted. A lot of them were physically impossible. They were, for the most part, sort of conceptual arguments. And so it continued. I mean, there are many things you just can't investigate experimentally, like the tides or, the motion of the planets. You can't do anything about them. But that's how modern science developed, by allowing yourself to be puzzled about what seemed like obvious things. There's another Galilean intuition which is worth bearing in mind. His conception, which then carried over to modern science, is that nature is simple. And it's the task of the scientist to prove it. So if things look complicated, you don't understand them. And try to figure out how they're really simple. That means that you have to be willing, as Galileo and his followers were, you have to be willing to put aside recalcitrant data, things that don't work. Almost nothing works. When you look at anything in the world, it's too complicated to study. But you have to sort of put that aside, even put aside what seems like conflicting data, and try to show how the conceptually correct conclusions somehow work if you understand things well enough. It's an attitude that guides research intuitions. And from small beginnings like that, tremendous enterprise, tremendously successful enterprise developed. This enterprise we call modern science. I mean, it's still the case that almost everything we look at in the world is incomprehensible, but those approaches have led very far, and it's worth bearing them in mind. Well, with regard to, say, language acquisition, the how questions, there are plainly going to be three factors involved. That's true of all cases of growth and development, growth of the arms, growth of the visual system, whatever it may be. And we can separate these factors and try to understand them. One factor is whatever the external data is. So an infant is placed in an environment, a complex environment, booming, buzzing, confusion, as William James called it. So that's the data. Then there are internal properties. a human infant has different properties from, say, a kitten. And those internal properties, back in the 17th, 18th century, they called them instincts. We would say genetic endowment. We don't know what it is, but there's got to be some genetic endowment that's specific to the child, that to the human, that enables a human infant to pick out of the complex environment around it some information which is language related. Actually, how this is done is a total mystery, but somehow the infant instantaneously, reflexively selects out of the environment language related information. That's something to be puzzled about. It's not obvious how it's done, and in fact it's not known how it's done. It evidently involves some prosodic, rhythmic features and a few other things, but it's basically not understood. Anyway, it happens, clearly. It happens very quickly. And then, almost reflexively, the child picks up the kinds of capacities that we're using. It's influenced to some extent by data, but say a Martian scientist with a different intelligence would regard all languages as essentially the same, just as we regard all bees as essentially the same when they carry out a waggle dance. Actually, if you look closely, individual bees do it differently, but and different bee species do it differently, but for us it's more or less the same. And it would be the same if we looked at humans from the point of view of from the perspective from which we study other organisms. So somehow or other, the child is almost reflexively picking up this capacity that we're now using. And then there's a third factor that's involved in all growth and development, and that's how natural law works. So there's no genetic instructions that tell a cell to divide into spheres rather than, say, cubes. That's just the way physical law works. And the same is true all the way through the process of growth and development. It's beginning to be partially understood in biology. It's called the Evo-Devo revolution, evolution development. In modern biology, it's pretty recent, and but finding pretty striking results. In any event, those factors have to be there. Something has to channel the course of growth and development, and incidentally also the course of evolution. Has to be channeled by more general principles, ultimately physical law. Well, these, in the case of language, it's a computational system, so a natural place to look is in principles of efficient computation. These probably hold quite generally throughout nature, but in the case of language, we want to see how they would operate, how do they interact with other factors in leading to growth and development. There's no satisfactory general theory of efficient computation, but some things are pretty obvious, like less is better than more. So a rule system, say X, is better than a rule system X plus Y, where Y has some extra rules. That's any theory of computation is going to have that property. Or minimal search is better than deeper search because it requires less computation. And there are other simple principles like that which are going to appear in any theory of efficient computation. And you can get pretty far, at least in our relatively primitive state of understanding. You can go pretty far by just appealing to simple principles of efficiency like those. Well, that's sort of the basic beginning. When you allow yourself to be puzzled and you think and you try to ask how these various factors can interact and why things turn out this way rather than others, you immediately notice right away that there's an enormous gap between the data available and the capacity attained. Now that's true in all growth and development. It's, in the case of language, it's considered controversial, but it's no more controversial than in the case of the development of the visual system. In the case of language, it's given a name only in language. It's called poverty of the stimulus, and it's considered some strange property we have to debate about. But it's a truism. the stimulus is impoverished in the sense that there's an enormous gap between the data available and the state attained. It's ubiquitous, hence also in the case of language. In the case of language, we can sharpen the question somewhat. Among the genetic capacities, we can distinguish, as a start at least, we can distinguish two types. One of them are general cognitive capacities, about which very little is known, but there are clearly general cognitive capacities that enable people, maybe other organisms, to learn things and so on. So they're general cognitive capacities. And then there are the capacities that are specific to the system of language, whatever, for example, those that enable the infant to pick out of the environment language-related information, to take the first, but much more. Those language-specific properties have been given a name, borrowing traditional usage and adapting it to a new purpose. They've been called universal grammar. Now that term has been misleading. Maybe it shouldn't have been used. It's used in this sense as just the theory of the linguistic, of the genetic component of the language faculty. That's what it is. There's a traditional usage in which it refers to things that you find in all languages. That's quite different. Many properties of the, say, genetic component of the visual system will not be found in all visual systems because they select among them for various reasons because of the interaction of the other factors. And the same's true here. So you have to distinguish two totally separate topics. One, what are the properties you find in all languages? One sense of universal grammar. Two, what's the theory of the genetic component of the language faculty? Separate question. And I'm not talking about that. That's the theory of I-language. For theoretical linguistics, a major goal from the beginning has been to try to reduce the richness and complexity that were attributed to universal grammar. The complexity of the data and the diversity of the data that you face in the early stages, say in the 1950s, seemed to compel those investigating the topic to postulate highly rich and complex principles of universal grammar. Now, there's a problem with that. One problem is just sort of normal science. You want to have simple answers, not complex ones. You want deeper understanding rather than a superficial description. But there's another problem, and that's kind of on the borders of, maybe on the distant horizons of research. There is an empirical question. How did language evolve? Maybe a question that we can't face. Maybe we'll never be able to face it. Some evolutionary biologists believe. Dick Lewontin is one. But at least it's there. It's a real question. And that question is going to be harder to approach to the extent that universal grammar is richer. To the extent that your theory of universal grammar is rich and complex, it's going to be harder to address the questions of evolution of language. Now, it's kind of an interesting curiosity that that elementary truism doesn't seem to bother people who work on evolution of language. And the reason is they're not working on evolution of language. There's a, there are international conferences, libraries of books and so on, all with words like evolution of language in them. And an interesting property of those is none of them deal with evolution of language. So if you take a look at a recent issue of Science magazine, the journal of the American Academy, the Advancement of American Association for the Advancement of Science, there's an issue a week or two ago, which is a very enthusiastic review of a recent conference on evolution of language, talking about how much progress there's been and so on. And if you read through it and you read through the papers of the conference, you notice that none of them have anything to do with language. I mean, they're all studies of, interesting, amusing data about what chimpanzees do and, what dolphins do, and so on and so forth. But there isn't the slightest reason to believe that any of that has anything whatsoever to do with language. There's no connection. And this is overlooked because of for a number of reasons. One reason is that there's a kind of a pop Darwinism, sort of a superficial version of Darwinism, which is not biology, but is very commonly held, even unfortunately by some biologists, which hold that everything has to happen in small changes. There have to be small changes. Anything that exists has to come from a long series of small adaptations, each of which is a little different than the one before it, and they're all directed by natural selection. Well, any serious evolutionary biologist will tell you that's perfect nonsense. I mean, that's not the way evolution works. And it's understood that it's not the way it works, but that's a kind of a popular conception. And therefore, human language, following this, must arise from small steps from animal communication. There isn't any reason to believe that. In fact, there isn't even any reason to believe that human language is a communication system. In fact, there's strong reason to disbelieve it. Come back to it. But that's kind of like an a priori assumption. And it leads to some very curious results. I mean, language is a system of infinite generation. I mean, that's not questionable. And you cannot go from finite to infinite in small steps. So there's no point trying. Can't be done. You can't go from a system of maybe, say, 4-word sentences to unbounded sentences in small steps. So you have to give it up. I mean, it's not, you can't approach the question that way. Another odd property of these investigations is that they do not ask what language is. What are you trying to solve?
It's just, well, you know, language is used by people that talk to each other, so we'll go on from there. It's kind of like studying the evolution of the eye, when all you know about eyes is that people use them to watch television. So, okay, now let's talk about the evolution of the eye. It really is at that level. It's a highly irrational subject, and in fact, the general discussion of language is itself highly irrational. In many respects, we could go into that, but it's true. In any event, if you're serious about it, there is going to be a problem of how did language evolve someday, and you're going to have to know what it is, otherwise you can't, to the extent that you know what it is, you can ask how it evolved. And one thing that it is a system of digital infinity, hence a generative procedure, recursive procedure, and we're going to have to account for how that developed and how it works. Come back to that in a moment. There's a traditional conception of language, goes back to Aristotle, which is a common sense conception, and that is Aristotle's formula is language is sound with a meaning. Okay, it's sort of right. Now that was considered sufficient for 2,000 years, 2,500 years. If you look at the history of the study of language, which is quite rich and complex, it almost entirely is concerned with the sound part. Sound in a broad sense. That includes phonology, morphology, all the ways of organizing the externalization of language, ultimately through the sensory motor system. And that's richly investigated. And it's almost the entire study of language. There's some study of meaning, or what's thought to be meaning, but it's missing something critical. The study of sound is really syntax. It's the study of symbolic manipulations inside the head until you get to the point where you attach the study to the sensory motor system. Well, that's acoustic and articulatory phonetics. That translates the phonological syntax, the morphological syntax, to actual articulatory motions, for example. Now, on the meaning side, if you want to really study semantics, there's a lot of extremely interesting work in formal semantics, which
is kind of like phonology. It's talking about the parts of syntax that are oriented towards ultimate interpretation at the thought interface. But it still isn't semantics, and it won't be until it relates that to something that's mind external, just as phonology goes beyond syntax when it relates the topic to, say, articulatory motions or perceptual operations. Well, how do you relate semantics, what's called semantics, to something mind external? It's done by a dogma. The dogma is called referentialism, the belief that the elementary units of meaning, say roughly words, are related to extra-mental objects by a one-to-one relation. So the symbolic entity cow is related to that thing over there, which, you know, you get milk from, and so on. Now, actually, animal communication works like that. As far as anyone knows, all animal communication systems do have a referential relation between symbols and extra-mental entities, and you can identify them. However, if you look at human language, it isn't like that at all. There's no relation between the symbols, the words, and anything that a physicist can identify. I won't go into it, but if you begin to investigate them, you find that that's ubiquitous. There just isn't any such relationship, which means that there isn't any study of real semantics. There are books, classic books, with titles like, you know, Word and Object or Word and Thing and so on. But they're based on the referentialist myth. And if you allow yourself to be puzzled and you say, well, what is the connection? You see it just doesn't work. Now that raises a huge poverty of stimulus problem. How does anyone, how do children find out the meanings of the words, since they aren't related to extra-mental entities, as you find as soon as you begin to look closely? It also raises a problem about evolution. How did it ever come about? The problem about evolution is too remote even to pose. The problem about acquisition could be posed, but not until you recognize the problem. So that's a topic yet to be investigated because the problem hasn't been understood. We haven't allowed ourselves to be puzzled about the relation between, say, the word river and, you know, the Seine and so on. And when you begin to allow yourself to be puzzled about it, you find that it's quite obscure. Well, that's two of the parts of the Aristotelian slogan, sound and meaning. One aspect of it that has barely been investigated up till the 1950s is the with part. It's sound with meaning. How are they connected? Well, there was an answer to that, more or less like the objects find their natural place. The answer is it's done by analogy. So it was understood that people, you know, produce new sentences. Well, it's by analogy with the old ones. That sounds like an answer until you ask yourself, what's analogy? And then it all falls apart. There's nothing you can say about analogy. Well, again, if you allow yourself to be puzzled, the science can begin. The inquiry can begin. You can say, well, okay, how does it work? Well, back in the 1950s, as soon as this willingness to be puzzled entered consciousness, immediately it turned out that almost nothing was understood. It had been assumed at that time that just about everything was understood. There were no real problems. You just applied the methods of structural linguistics and the procedures and so on. You got all the answers. If you want to talk about language acquisition, conditioning, reinforcement, have all the answers. Turned out as soon as people started looking at it, it wasn't that everything was understood. It was that nothing was understood. Everything you looked at was a puzzle, even the simplest things. And some of those puzzles, incidentally, remain. Some of them have yet to be recognized as puzzles. I'll talk about one. One of the earliest examples that was given, there were a host of them, but there's one that kind of took on a life of its own. It's a very simple example, so I'll put it on the blackboard. So take the sentence, say, can, it's not white, unfortunately. Can eagles swim? Okay, oh, can I use that? Can I use that? Not working.
It's not working? Yes.
Does that work? Can you hear me? No. How's that? Okay. I'll pretend I'm eating it. Okay, so take the sentence, can eagles swim? How do we understand it? Well, we're asking, the word can is actually serving two functions in the sentence. It's what's called displaced, meaning two functions. On the one hand, it's indicating that it's a yes or no question. On the other hand, it's connected with swim. Okay, you're asking about the capacity to swim. And in fact, if you look at it more closely, it's sort of semantically, it appears over here. It's related to eagles can swim, and it's saying, is it true that eagles can swim? That's the question. That also shows up in the inflectional system, not just semantically. So, for example, if I said, are eagles swimming, the R would have the same relation to the inflection that it has when it appears over here. Eagles are swimming. Furthermore, the item that's displaced is actually just the inflection and whatever may happen to be attached to it. You can see that clearly in English, where you can move the inflection but not any verbal element. And when you do, you have to make up a dummy element with no semantic content, namely do, which carries the inflection. So, say, suppose it was past tense, it would be did eagles swim? And it would be related to eagles did swim, eagles swam. So this item here actually appears in two positions. It appears in the initial position where it yields the interpretation, a yes or no question, and it appears over here where it gains its inflectional properties and its semantic properties. Okay, let's call that displacement. A good question is how it works, and I'll come back to that. This alone is enough to tell us that the structures that are involved are actually some sort of a nominal phrase and an inflectional element, which is usually called T, just for tense, but it means all the inflections, and some verbal phrase that's associated with it, and these two things are related. So this is some kind of a phrase which is an inflectional phrase, and the inflectional element can go out here and give you displacement. Well, there's another property of this example which is universal. You don't pronounce both of the elements. You only pronounce one of them. And the one you pronounce is the hierarchically highest one. Okay, this whole thing is a clause of some kind, and the can is out here in what's called the complementizer position. Let's write it just as C. Outside the clause, and depending on what the complementizer is, it'll be a question or an imperative or declarative or something else. And it's the T that's raising to the C position. That ought to raise puzzles, questions. I'll come back to the questions, but they haven't been noticed. They haven't been noticed. It's just been stipulated that that's the way it works, and there are problematic elements to it. Like, for example, why does the highest, the prominent element of this thing, call it a TP, a T phrase, why is it that raises? Why doesn't the most hierarchically highest part of the noun phrase raise? You wouldn't see it in this sentence, but suppose the sentence was, can smart eagles swim? Why don't you form the question by just raising eagles? So it would come out, eagles, smart, can swim. Why isn't that the yes or no question? I mean, it seems ridiculous, but it also seems ridiculous to say, why do apples fall down instead of up? However, it's no more ridiculous than that. And when you begin to ask the question, it turns out to be non-trivial. There's no trivial answer to why you don't raise the noun phrase and you do raise the inflection. It's been assumed, meaning just stipulated, and it kind of has, only because it's like apples fall. It's obviously correct, so we stipulate it. But to stipulate it means to claim that it's part of universal grammar. And that means we're now posing, first of all, we're not getting a deep explanation, we're stipulating it. And secondly, we're posing just another problem for the eventual study of the evolution of language. Why did language evolve that way? After all, eagles smart can swim would be a perfectly fine way of asking a question. It's just that language doesn't work like that. So there's got to be some reason for it. And we can stipulate the reason in universal grammar, but that's not an answer. That's rephrasing the question. Well, actually, that's a poverty of stimulus problem. There was another poverty of stimulus problem which was raised since the 1950s. And that comes along when you make this a little more complicated and put in here a relative clause. So suppose it's, can eagles that fly swim? Okay, so can eagles that fly swim? Well, we know how to interpret that. The can goes with swim. It doesn't go with fly. You're not asking, is it the case that eagles that can fly swim? You're asking, is it the case that eagles that fly can swim? Well, that's puzzling, or it ought to be puzzling. It never was. You look through thousands of years of the study of language, it was never puzzling. It's just, that's the way it works. But it is puzzling. Why does it work that way? And so, for example, it would seem to make sense that relating can to this position would be simpler than relating it to its actual position, because it's a shorter distance. You're counting less, if you think of it in terms of raising, you're raising the closest element, not a more remote element. So why is that the case? Well, that's one of the earliest examples of poverty of stimulus that was discussed, and there is an easy answer to it, or what seems like an easy answer, namely distance from the C position to the tense is closer if you measure distance structurally, not linearly. So if you just think about the structure of the construction, I won't draw it all out, the distance between the actual interpreted position and the C, the front, is minimal structurally, though maximal linearly. So it appears that language is using structural minimality, not linear minimality. That's called the principle of structure dependence. It's kind of a bad name for it, but it's basically minimal distance structurally. That seems to be the principle that language uses. Now, these properties that I've mentioned are universal. They're in every language. So you never use linear distance instead of structural distance. You never fail to pronounce the higher thing, and you never fail to not pronounce the lower thing. These are just, you always pick the inflectional element, never the main element, the nominal phrase, and so on. So everything, they show up differently in different languages, but in one way or another, these properties show up in every language and in every construction. So there's something far-reaching about them. Well, how can you go on to the why questions? So why should you use structural rather than linear distance? Well, one possible answer, the one that comes to mind right away, is that language just doesn't have counters. It doesn't have a way to count. Universal grammar doesn't have a way to count. You can't form the negation of a sentence, let's say, by taking the third word and putting it in front. It doesn't work like that. Why should language not use linear operations? Well, there could be a deep answer to that, namely the whole externalization process is just not part of language. It's it's a reflex of the sensory motor system. So the sensory motor system does require linear order. I mean, you can't talk in parallel. You have to talk in time. So it imposes linear order. And therefore, it would make sense to think that the process of going from the internally generated structures to the sensory motor system add order along the way. Okay, they would require order because the sensory motor system does. Well, that conclusion is fortified by the observation, apparently correct observation, that semantic interpretation doesn't require linear order. It requires hierarchy, but not linear order. Now, that's contested and debated, but it seems to be pretty well confirmed. Well, if that's the case, then there would be no reason for the I language, for the generative procedure, to impose linear order on the path to the thought system, okay? Only on the path to the sensory motor system. So therefore, if that's correct, then linear order would not even be available for these operations. It wouldn't be there. So the question of linear closeness would never arise. Well, that looks like a good answer. There's some problems with it. One problem is that there appears to be empirical evidence that syntax, though not semantics, does require linear order. Okay, now we're in the Galilean conundrum. There's an answer that ought to be true, just on conceptual grounds, and there's empirical data which seems to conflict with it. So we get conflicting research intuitions. No point arguing about them. We could just identify them. One is the Galilean intuition. The data aren't understood. So let's proceed to understand the data and show that really order is imposed by the sensory motor system. The other is to say, well, I'm stuck with the data, so we'll throw out the natural conclusion. You just have to pick your own research intuition at that point. My own is, as you can guess, the first. I don't like data. But that's a common situation in the sciences all throughout, and here too. There may be another answer to this, which doesn't involve this principle. I'll come back to it in a minute. Even if we do accept this, it still leaves the first question. Why is the displaced element the inflection and not the noun? Still leaves that question. Well, in order to... actually, I should say on the side that I mentioned before that almost all the investigation of language, like 99%, has been externalization. It's been morphology, phonology, linear order, things like that. And that makes good sense. That's the data that's immediately visible. You can see it, You see the phonetic, you hear the phonetics, the order, and so on. It's also the domain in which languages appear to vary. There's a lot of variation in externalization. It's highly subject to historical accident. So it's the area of language that changes very quickly. So you have the Norman invasion, and you start pronouncing things differently and so on, different words and so on. It's also, it's the hard problem of acquisition. So if you're trying to learn a second language, you have to learn the phonetics, the morphology, the inflectional systems, the order of the words, and so on and so forth. You don't learn the semantics, and you don't learn the syntax. In fact, if you had to learn them, you'd never learn the language, because nobody can teach them. Nobody knows what they are. Those things are somehow just come automatically. And those also seem to be the parts of language that are pretty much invariant. To the extent that we understand them, they're essentially invariant. Maybe totally invariant if we understood enough. But the variation and the complexity is overwhelmingly in the externalization process. Well, all of that once again suggests, and there's stronger reasons for it, that the externalization problem is probably ancillary to language. It's a secondary process. It's a secondary development. There is the language, the I language, the semantics, the relation to the thought system, kind of a language of thought, if you like. And then tacked on somehow is externalization. And it's a difficult problem. You have to the sensory, if you think about it from an evolutionary point of view, we don't know much about the evolution of language, but a few things are pretty clear. One is that language evolved pretty recently, so there's no evidence for it in the archaeological record up to maybe 100,000 years ago or something like that. After that, there's a kind of a burst of creative activity that shows up in the archaeological record. Complex symbolic representation in the arts and the representation of astronomical events, complex social structures. Also, it's sometimes called the Great Leap Forward. There's a huge increase in sort of creative imagination that shows up in the archaeological record, and it's generally assumed by paleoanthropologists pretty plausibly that that's related to the evolution of language. The evolution of language gave the capacity to think and to do all kinds of things. So probably around that time, maybe somewhere around 100,000 to 50,000 years ago, it doesn't, exact dates don't matter, but sometime around then, language evolved. Well, what had to evolve was the operation that produced digital infinity. There can't be any precursors to that. As I mentioned, there can't be precursors. It's just like the number system. Either you have it all or you don't have any of it. There are no precursors. There's a lot of talk about proto-language and so on. There's no empirical evidence for it, no conceptual reason for it. It's just mythology. So something happened around that time which yielded the capacity for infinite generation. Well, it had to be a mutation of some kind, maybe a small mutation which rewired the brain somehow to give this process. Mutations take place in an individual, not in a group. So it happened to some person. There's a couple of marginal exceptions to this, but we can put them aside. Like a mutation in a germ cell could have hit many individuals. But basically it takes, a mutation is something that a person undergoes. Now that person would have had the capacity for thought, it would have a capacity for infinite generation of hierarchical structures which relate to whatever conceptual apparatus was around prior to that, the thought system, a mystery, but that's the other mystery I mentioned. However, there would be no point in trying to externalize it because nobody else has the capacity. Okay, so it's inside. Well, you know, such a mutation could have selective advantages. It's not obvious, but it could at least. And it would be transmitted partially to offspring. If there are real selectional advantages, it could take over a small breeding group. Our ancestors were very small in number, maybe thousands. At that point, there becomes a reason for externalization. A lot of people have the capacity, maybe they decide to try to figure out a way to externalize it so then they can interact. But that's a secondary process and a hard problem because the initial system developed without any pressures on it, no selective pressures, just developed. And therefore you'd expect that it would develop into a perfect system, something like a snowflake. It just develops with no external pressures, hence by virtue of the laws of nature, by the principles of efficient computation in this case, with whatever constraints are imposed by the structure of the brain about which we know nothing, so we can't talk about them. So you have this essentially perfect system on the inside. You have the sensory motor system, which had been around for hundreds of thousands of years without any change as far as anyone knows, and you have to relate them somehow. Okay, it's a hard cognitive problem. It can be solved in a lot of different ways, and that's where you get the complexity and the variety and the susceptibility to change and so on. So roughly speaking, it all sort of falls into place. And it would be nice to show, and I'll come back to showing it in a minute, that in fact there are design features of language. By design, I don't mean anybody designed it. There are just intrinsic features of the nature of language that do show that strongly indicate that language is designed as a system of thought and not as a system of externalization. Notice that communication is a subcase of externalization. So it's not even secondary, it's tertiary. Plenty of externalization that isn't communication. And there's nothing special, we now know, there's nothing special about the auditory articulatory mode of externalization. So sign works exactly the same way as far as anyone knows, and could turn up to work out in other modalities as well. Whatever it is, it seems to be independent of sensory modality. The auditory mode has its advantages, and you can do it in the dark and so on, but it doesn't seem to be intrinsic to language in any way. Well, let's proceed. What is this mysterious recursive operation that somehow entered into our evolutionary history? The first assumption you would make is it's the simplest one imaginable. Well, what's the simplest one imaginable? Any recursive procedure, any algorithm that's going to create a system of digital infinity is going to have embedded in it somewhere an operation that says, take two units that have already been formed and make up a bigger unit. Okay, somewhere in any system you're going to find that, whether it's an axiom system or a Phrygian ancestral or whatever mode you have for generating an infinite number of objects. So let's take a look at that operation. Let's assume that the initial assumption, certainly, is that's the operation that was provided to some not so remote ancestor. 100,000 years is not a long time from an evolutionary point of view. So some recent ancestor had some rewiring of the brain which gave them this operation. Call the operation merge. Takes two objects already constructed, forms a new one. Well, we'd want it to work in the simplest, we'd assume that it would work in the simplest possible way. The simplest possible way would mean that the two that are, so in other words, I won't bother writing it, but suppose you have X and Y, you form a new object, call it Z. Okay, the most simple assumption is that X and Y are not changed by the operation. That's the minimal amount of computation, okay? They're not changed by the operation. That's called the no tampering condition. It's an elementary principle of efficient computation. You want to put two things together, don't change them. And furthermore, don't order them, because ordering them is more complex than leaving them unordered. Okay, what that means is that when you merge X and Y, you just get the set XY, period. Okay, that's the simplest operation, so presumably that we start by assuming that that's the only operation. If we're forced to, we'll add more complexity, but that's the minimal form of universal grammar. You have a perfectly functioning operation merge. Well, if you think about it, there are two possible kinds of merge. We see that right away. Let me write it. Okay? Yeah. So suppose we had X and Y. We want to merge them in the simplest possible way, and that will be the set X, Y. Okay? So for example, in a linguistic case, we have, whatever that sentence was, say, tense and swim, and we have already, say, picked these out of the lexicon, and we merge them, and we get the set tense swim. We add eagles on here, and we get this. Okay. There are two kinds of merge, just as a matter of logic. One of them will work like this. You take two things that are formed, stick them together, don't change either of them. That's called external merge. The two things that you put together, eagles and this, are separate from one another. They're distinct from one another. That's one possibility. The other possibility is they're not distinct from one another. That's logic. Well, let's say this one is can, Suppose we merge can with this whole thing. That's the case where they're not distinct from one another. Well, then we get can eagles can swim. Okay, that one's called internal merge. And those are the two kinds. I mean, if you think about the process of generation, there aren't any other kinds. You can't get overlapping sets. There's no way to construct them by this operation. So either the two things are totally separate from one another or one is contained within the other. Well, if it's contained within the other, this one, then you get two copies of this. It appears twice. Okay. Now, that's the simplest possible operation. You can only block it by stipulation. You'd have to add something to universal grammar to say you can't do it. Okay. Now, there are lots of approaches to formation of these constructions that are, you know, HPSG, LFG, those of you who know the literature, which add complex operations. But they face two problems. One problem is, why do they bar the automatically available operation? That's a stipulation. Second, why do they add the other operations? Now, I don't think either of those questions can be answered. So therefore, as far as I can see, the other approaches just aren't in competition. They just involve too many stipulations. Now, there's a historical reason why that's done. But so no, we should forget it. The historical reason is that external merge was taken for granted, was assumed to be just available. Internal merge, which was called transformations, was considered to be, by me too, it was considered to be something extra. You know, something you have to add on because that's the way language seems to work. And therefore there were many efforts to try to get rid of it. But when you think about it, you don't have to get rid of it. It's automatic. Now, if you take a look at the history of modern linguistics since the 1950s, a major effort has been to cut back universal grammar to try to show that it's not as rich and complex as was assumed. Through the the original assumption was that it included phrase structure grammar and transformational grammar. Through the 1950s, manipulations and complexities, but they were sort of, ways were thought of trying to overcome them. It led to what's called X-bar theory, which essentially eliminated phrase structure grammar pretty much. You could make further steps, but got rid of a lot of it. In the 60s and on, there were efforts to whittle away at the complexity of transformational grammar, and they reached considerable success by, say, the 1980s. So you had two systems, but simpler ones. The next question was, can we reduce them to the same operation? Well, that turns out to be possible, in fact necessary, namely merge. They're reduced to the same operation. Okay, now you've reached the limit, you know, aside from things you don't understand, which is enormous. You've reached the limit of what can be done to reduce universal grammar to its absolute minimum. If you can get away with this, that's the absolute minimum. To get away with it, of course, you have to show that everything else follows, and that you can solve the poverty of stimulus problems. Well, that looks right, and we now have, you now notice something, that in the internal merge case, you pronounce the structurally highest element, but you don't pronounce the structurally lowest element. Well, actually, there's an economy reason for that, too. The pronunciation aspect, first of all, notice that what's given by internal merge is exactly correct for the semantics. For the thought systems, you do want to know that that element appears in two positions. It gets its semantic interpretation from the original position. It gets its interpretation as a forming a question from its derived position. And that's, and you only pronounce the higher one. Well, that you find all over the place. So to take a different kind of case, consider the first and most famous and most honored suicide bomber. His name is Samson. According to the Bible, Samson was killed voluntarily. That is, he chose to be killed, and it was his great achievement. He killed more Philistines in his death than his entire lifetime. So he's the archetypical suicide bomber and highly honored. But notice that the words, we have the same problem, the same configuration here that we had in the yes or no question. The word Samson is heard, it's pronounced only in the hierarchically highest position, but it's interpreted in another position, namely the position which I indicated just by a slash, by a bar. It's interpreted as the object of kill. Okay, so something killed him. And it gets its semantic role, and that would be a position of external merge. But the raised position, the position of the actual sentence, is one of, it's gotten by internal merge, leaving two copies. And notice that it gets a semantic role in both positions. In its original position, it's understood as the object of kill. In its raised position, it's the subject of the predicate voluntarily. It's being killed that was voluntary, okay? So it gets two semantic roles, and they're different in character. One of them is called a theta role, one not, but it doesn't matter. It's getting two semantic roles in two positions. The internal merge is giving exactly the right structure for thought, but the wrong structure for pronunciation. In both the yes or no question and this case, the pronunciation is different. Why is it different? Well, there is an economy principle, simple one. Articulation is a costly operation. It takes a lot of brain energy and takes a lot of articulatory energy. And you want to do as little of it as possible for economy reasons. Okay, so we have two economy principles. One that gives the two copies, one that that only pronounces one of them. I mean, you have to pronounce one of them, otherwise you don't hear that anything happened. And it has to be the hierarchically highest one, otherwise there's no indication that the operation took place. So the minimal computational operations will say, construct the sentences by internal merge, yielding the semantically appropriate conclusions. That's fine for the language of thought. But then when you map it onto the sensory motor system, just pronounce the highest one. Okay, there's some interesting marginal exceptions to this, and there's an interesting literature about them, but I'll put that aside. The exceptions are pretty well motivated, but the core principle is this, and it's just universal, all over the place in language, all languages. Well, there's a consequence. Pronouncing only one yields perceptual problems. You have to figure out where's the other one. Those of you who've worked on parsing programs or perceptual models know that that's a very serious problem. In fact, it's the core problem in parsing. It's called a filler gap problem. You hear the word what in the front of a sentence and you got to figure out where it's coming from. I mean, that's the major parsing problem, and similarly perceptual. And these are trivial sentences, but when you get more complicated sentences, it's a very hard problem. And it turns out that there are copies all over the place, and they all enter into semantic interpretation, but you don't hear any of them. So you get real problems of interpretation. Well, if you notice, that's a problem of conflict between computational efficiency and communicative efficiency. The communicative efficiency would be far easier if you pronounced everything. Okay. Computational efficiency is better if you pronounce only one. Well, computational efficiency wins in the conflict 100%. And furthermore, it's ubiquitous. It's true for all other constructions and all other languages. Well, what do we conclude from that? We conclude that the actual design of language, the way it's sort of put together, is for the purposes of semantic interpretation and computational efficiency. Communicative efficiency is sacrificed, which makes sense if that's a secondary process. You know, something comes along later, okay, we do it in some complicated way. Well, there are many other examples of this. So, for example, ambiguities. There are lots of ambiguous constructions, structurally ambiguous constructions. As far as we understand, they're all, anything we understand, it's generated by just letting the rules run free. You let the rules run free, you get ambiguity. That's bad for perception and parsing. There's a category of expressions called garden path sentences. It's the same. They are generated when you just let the rules run free, but they yield problems in perception and parsing. A more interesting case, which is only partially understood, is what's called islands. There are certain expressions which you can think, but you can't say. Like if you have the sentence, I wonder how John fixed the car or something. You can question the car and ask, which car did you wonder whether John fixed? Maybe awkward, but intelligible. On the other hand, you can't question John. You can't say, who do you wonder how fixed the car? It's perfectly good meaning, you know, so you can think it, but you just can't say it. You have to find some circumlocution to express that thought. Okay, that's an island. Now, as far as we understand islands, and it's limited, they seem to come from satisfying conditions of computational efficiency, but they yield communicative inefficiency, actually inefficiency even in ability to express your thoughts. So it's another kind of conflict. This is a research area, a lot of open questions here, but and interesting ones. But where we understand anything, it looks as though computational efficiency wins out automatically over communicative efficiency, which is just not a relevant topic. Am I getting late? Yeah. Okay. I'll speed up. Let me. What did I skip? All right. Let me come back to the original question that I raised. Why do you? Here's something we should be puzzled about, but nobody has been puzzled about in the modern history of the subject or the traditional one. In the case of, say, smart eagles swim, if we want to form a question, why do we raise the inflectional element but not the nominal element? Actually, there's no good answer to that. They're on a par. You know, neither is structurally closer to the complementizer than the other. This has been handled in the past by just calling the subject the specifier of the tense element. But that's just a stipulation. You could just as well call the TP the specifier of the nominal element. There's nothing, no principled reason to do one rather than the other. It's just been done that way because it's right. But now we're back to Stone's Fall, you know, because it's their natural place. We want to know why it's right. Well, if you think it through, there's only one reason why it could be right, and that is that the subject isn't there when this relationship between C and T is established. The subject just isn't there. So therefore, there's no other way to draw the connection other than with the T. Well, if the subject isn't there, it's got to be somewhere else. Where is the somewhere else? Well, there is a widely held belief that the subject actually is formed by external merge inside the verb phrase. Now, there's some arguments for that, empirical arguments, but they're not overwhelming. There's a kind of conceptual reason for it, Namely, the semantic roles are given in the domain of the verb. And it would be nice for them to be close together. But now we have a powerful reason for it. The subject just has to be there and later raised to the surface position where you hear it. And the connection between the C and the T is established before you raise the subject. Okay, then everything works. And that's a principled reason to, for why the inflectional element is raised, but not the nominal element. Now that has another consequence. It takes care of the poverty of stimulus problem without considering linearization. If the subject isn't there at the point where the operations apply, you never get the poverty of stimulus problem about a linear order versus structural order. So it may be that you can get a deeper answer to the question of why the original poverty of stimulus problem doesn't arise. Actually, just as an aside here, I might mention that there's something quite curious about this poverty of stimulus problem. It has taken on a life of its own. There's a huge literature trying to solve it on other grounds, like statistical analysis of corpora. Huge literature in computational cognitive science saying, well, you could get this result just by complicated statistical analysis of a corpus. There's some strange things about those efforts. One of them is that they all fail, not marginally, but colossally. They all totally fail. There's literature on this, I won't go into it. The second is that even if they worked, it would be irrelevant, because this is of no interest to show how a child could have acquired it. We want to know why every language works like this. I mean, if the result is acquired by analysis of a corpus, we'd expect, randomly that languages would pick one or the other approach. You could do the linear order by analysis of a corpus too. So even if the approaches worked, which they don't, they would be irrelevant. They're not addressing the question, why is it universal? We're talking about universal grammar. The third curiosity is that there does seem to be a straightforward answer in terms of structure dependence, and now when we improve it, in terms of late insertion of the subject internal to the structure developed. Now, if you think about it, this late insertion of the subject seems to be counter-cyclic. First, you have to form the C, and then you have to raise the subject internal to the C that you formed. Well, there is an approach called phase theory which predicts that on other grounds. I won't go into it. But this would be more evidence for that theory, saying, yeah, that's the way it works by phase theory, which predicts that that should happen. There's a next question that arises, namely, why does the subject raise from the verb phrase? Why doesn't it just stay there? Okay. Suppose it stays in the verb phrase, where it's inserted by external merge. So you have a subject and a verb phrase which are externally merged, they're paired. The standard assumption is the subject is the specifier of the verb. Okay, I'll stop in 1 second, I'll stop. This, I won't write it. The usual description, what you find all over the literature, is that the subject is the specifier of the verb, but we're not allowed to say that, just as we weren't allowed to say that the surface subject is the specifier of the TP. That's just an arbitrary stipulation. We say it because it's intuitively right, but you're not allowed to. That's adding a stipulation. What you just have is two elements, the subject, and the verb phrase, and they're just a set, the set of those two. Neither is the specifier or the other. Well, there's a problem with a unit like that. There has to be a way of identifying configurations for them to be interpreted by the sensory motor system and by the semantic system. The semantic system, both of those systems have to know what they are if it's going to interpret them. It's going to interpret noun phrases differently from verb phrases. So there has to be some kind of an algorithm. It's called a labeling algorithm, which looks at a unit and says, okay, this determines what you are. Now, the optimal algorithm will be a minimal search operation. That's probably a law of nature, just minimal search. If you have a TP, it gives you a nice answer. It picks the T, because the T, you have a T and a VP. The T is the entity that you find most quickly if you do search from the outside. It's the most prominent element. On the other hand, if you have an NP and a VP, the search is ambiguous. Do you look into the NP or do you look into the VP? So you can't label it. Well, if you can't label it, you can't interpret it. That's okay for syntax and phonology. This element, subject, verb phrase, never functions in the syntax, like it doesn't raise, say, or it doesn't extrapose, and so on. On the other hand, it does get semantically interpreted. That's where the semantic roles are assigned. So it has to be labeled. And we want it to be labeled V, because that's right, you know. It's the way things work. How does it get to be labeled V? Well, there's two possibilities. One possibility is to raise the subject. If you get rid of the subject, then what's left is the copy of the subject and the VP. Well, the copy of the subject can't be seen by the labeling algorithm because it's a piece of a discontinuous element. I can't see it. It can, however, see the VP. So the whole thing gets labeled V, which is what we want. Well, that's a partial explanation for a mysterious property of language called EPP. Something's got to move to the surface subject position. There's more to it than that, but that's at least part of it. There's another way to make the entity labelable. That's to raise the object. If you raise the object, what you're left with is the subject, a V, and a copy of the object which you can't see because it's part of a discontinuous element. So once again, it's labeled V, which is what you want. Technically, the subject is the complement of the V once you've raised the object. Well, there is a general principle that seems pretty well established that you have to raise either the subject or the object. There's interesting work on this, a lot of evidence. This could be the reason. You have to raise either the subject or the object because if you don't, the entity is unlabelable and therefore can't enter into semantic interpretation. So we might get we might draw that empirical consequence, which seems to be well established. Things go on. Suppose there's an indirect object. Well, that can't be there because if it is, you're going to be back in the same paradox again. So that means the indirect object, traditional grammar must have been right when it called the indirect object indirect. It's coming from some other dimension. It's not like the object. And there is another dimension, namely a kind of merge that provides pairs rather than sets, pair merge. So it must be that the indirect object is coming by pair merge and really is indirect and isn't seen by the labeling algorithm. And the same would have to be true of adverbial phrases, prepositional phrases, and so on. That leads all over the place, where I won't go. Similar problems arise about coordination, many other things, but I'll drop it there. Anyhow, final conclusion. If we agree to be puzzled about simple things, instead of just taking them for granted, like apples fall from a tree, all sorts of directions open up. And they're pretty fascinating ones and lead to pretty rich conclusions, even quite general conclusions, like why externalization of language and hence communication is an ancillary process, not a core process of language. And lots of questions about language design, which come closer to the goal of showing that there's nothing in universal grammar but what has to be there by laws of nature, given that merge appeared somewhere. It's kind of a distant goal, but one that would be interesting to try to approach. I'll stop there.
I I think we are going to have 30 minutes of questions, 30 minutes de questions. Ça va?
Sorry. I would like to ask a question about merge. Does it apply to sets? Sorry? Sorry. Yes. A question about merge. Does it apply to sets or labeled sets? Because if it applies to labeled sets, does it imply that the subject is externally merged on the face after VP? So it's externally merged at the TP level. And related to an evolutionary pathway, does that mean actually that labeling was there prior to merge?
Yeah, in my own work, everything that's published, I've assumed that labeling is prior to merge. So then comes the story about how you merge is a more complex operation, which actually produces a labeled set, so a bigger. But I think that was just a mistake. Labeling ought to be a general algorithm that's just part of the computational process, and it applies. Wasn't talking. Labeling ought to be a general algorithm that's part of the computational process. It's not part of universal grammar. It's just part of natural law, which says if you want these objects to be interpreted at the two interfaces, semantic and sensory motor interfaces, you're going to have to say what they are. And that operation ought to be optimal, which means it ought to be a minimal search operation. And hence the merge itself should be purged of that, I think. It doesn't provide labeled sets, it just provides sets. If they can be labelable, they are labelable. Sometimes they can't be labeled, like in cases where they're just XP, YP sets. Well, in that case, something has to be done. Like in the case of the VP, either the subject or the object has to raise. The case of the specifier and the TP is an interesting one. See, it does seem that is labelable. In fact, that's how you get voluntarily to be predicated of Samson. The only way I can think of for that to be labelable is to appeal to the fact that the specifier and the TP do share properties, namely the phi features. They share, the inflectional properties. And it may be that the labeling algorithm looks at them and sees these properties in both cases, so it says, fine, we can label it with those properties. That introduces a notion of spec-head agreement. Spec-head agreement is appealed to all over the place. It never made any sense. Spec-head agreement was a case of what's called technically M-command. It's not minimal search within a unit, but it goes up higher to a bigger phrase and searches bigger units, and that opens the door to all sorts of unwanted consequences. But this could be a way of capturing the property of spec-head agreement without appealing to anything except optimal minimal search. There's another case of this, which in fact suggested a lot of it, and that's Andrea Moro's work. Andrea Moro's work on copular structures. Those of you who know the literature will know that he argued that copular structures have a copula and then a small clause. And the small clause is just an XP, YP. And he argued that one or the other of the XP or YP has to raise. And which one raises gives different interpretations. Okay, he had a theory about this in terms of dynamic asymmetry, but I think we can maybe eliminate that theory and just say, yes, one or the other has to raise, otherwise it's uninterpretable. So it's kind of like the Alexiadou Anagnostos, I can't pronounce it, the A squared, famous A squared article by the two Greek women, summarizing why either the subject or the object has to raise. It could be that same paradigm. And then the same thing would occur maybe with spec head. Actually, that carries over to something else. See, one of the problems that arises when you pursue this is with embedded questions. So I wonder which book John read. You're getting which book, which is an XP, and a CP, headed by the question particle and the rest. Okay, that's unlabelable again. So what happens? Well, one possibility is that the WH phrase has an operator in the head, and the CP has an operator in the head. So it kind of looks like spec head agreement. You know, you can pick out the operator by the labeling algorithm. It may be a way of approaching that problem. And there are a lot of, as soon as you pursue it, there are questions all over the place. But that's what happens when you allow yourself to be puzzled about simple things. You suddenly find that nothing is intelligible. So we have problems all over the place, and we have to look for them. And when you pursue them, you often find some interesting answers, you know, like your case, which I didn't have time to get to. I can't hear. Is it? Somebody.
I have a non-expert question, but I'm not the only non-expert in the room, I hope. It seems that you want to infer everything from the poverty of stimulus argument. But I've just a naive question. Did it ever occur in your investigations that starting from native English speakers, you infer something from poverty of stimulus argument that must be universal, and then you discover that in some other languages, maybe Latin American one, New Guinean one, something, you don't have these universal features, and therefore there was more in the stimulus, if you wish, than you would have thought a priori. That's the question.
Yeah,
Does it occur? I mean,
sure. I mean,
it's difficult for me to see exactly, you know,
that's
how
why
do
it's
you know
right.
how poor the stimulus is.
Well, that's why it's an empirical subject. You can imagine data which would falsify the conclusions. And if you come across data which falsifies the conclusions, well, then you're in the Galilean paradox. What do I do with the data? What do I do with the conclusions? But at least in the cases that I mentioned, I don't think that there's any contrary evidence. When you go beyond, you're going to find what appears to be contrary evidence. Actually, I mentioned one case with regard to linearity. So there's a conceptual argument that you shouldn't have linear order in the syntax. To repeat, it has two aspects. One, it doesn't seem to appear in the semantics, and the syntax is feeding the semantics. So there's no motivation for it to be in the syntax. The other is that there's a strong motivation for it to be in the externalization, because there it's forced by the sensory motor system. So the natural conclusion, you know, the conclusion that Galileo would have liked to see if he'd thought about it, is that it's added, that linearization is added only in the externalization, the secondary aspect of language. On the other hand, there is empirical evidence that it does appear in the syntax. So that's kind of your case. So what do? Well, here we have the conflicting research intuitions. And the same would appear if we found contrary evidence in some other language. So if we found some other language, let's say, in which the eagles that fly can swim, if we found that it's the fly, you get can eagles that fly, swim, meaning can fly. If we found something like that, it would be counter evidence. But nobody expects to find any evidence like that. In fact, it's almost unintelligible. I mean, you can express it, but you have to work. It's probably just totally inconsistent with, not even with universal grammar, just with properties of computational efficiency. So there's kind of an interesting historical phenomenon here. From the 1950s, it was understood by everyone working in this area that you want to try to reduce universal grammar, okay, for obvious reasons. You want better explanations, and you hope that someday it'll be possible to formulate at least a coherent question about evolution of language. So for those two reasons, you want to reduce universal grammar. Well, there have been all over the field and related fields, it's been understood that you want to reduce it. And there have been many efforts, a lot of efforts from computational cognitive science, connectionism and so on. They have all multiply failed. One, they fail in the narrow sense that they don't deal with their own questions, and two, they would be irrelevant if they succeeded for the reasons I mentioned. So they're just a waste of time. There are suggestions within the biological literature, what you mentioned to me yesterday, that somehow epigenetic properties take place. So there's interactions among the genetics, between the genetic structure and the data. Well, that could be. Some things like that are known in biology. It wouldn't change anything. You still have the same three factors, and there's no evidence for it. So it's just, you know, it's just saying, well, maybe things are more complicated than they seem. Yeah, maybe. And if you can find some evidence for it, you consider it, otherwise not. Now, there's a third approach to reducing universal grammar, and that's the approach that has been followed within theoretical linguistics. And it has reduced it considerably. Reduced phrase structure grammar, reduced transformational grammar, may actually unify them. So we have one approach that's worked and has worked very effectively. We have two approaches which have zero consequences. And somehow the general feeling is, well, it's the ones that have zero consequences that have to be pursued, and the one that keeps working is somehow controversial. It's a curious fact about the way the field is looked at.
Sorry for raising a technical question. It has to do with what is broadly known as multiple spell out of WH phrases. Some of those cases I've been investigating over the years, in particular in the northern Italian dialects, where you get a WH word to the left and a bottom WH word, both playing the same semantic part in the sentence. So my general question is, how would economy, in your sense, deal with that?
Yeah, I sort of made a fleeting comment about that when I said there are some exceptions to the fact that you never pronounce the lower copy. But in every case like that that I know of, what's pronounced below is a small piece of the thing that's higher up. Like, you never pronounce which book did you read down below. I mean, there's one exception to this that I've heard of, and that's Afrikaans. But I don't know if the data is very well accepted. But I don't think that's true in the northern Italian dialects. I mean, you don't pronounce the whole phrase multiple times. Like if you have successive cyclic movement, you don't pronounce the whole phrase every time there's a copy. You pronounce a piece of it. I mean, German is a well-known case. You have a was that you stick in there. If you look at that, it seems to me to belong to a different category of phenomena. There are a lot of marks of successive cyclic movement. So, for example, Esther Torrego found years ago that you get verb raising in Spanish as a mark of successive cyclic movement. There's evidence, Chris Collins and Sandy Chung and others have found cases where you get special agreement markers in positions where you've had successive cyclic movement. There's a case that Doug Satie found in Indonesian where some morpheme appears at the VP in the cases of successive cyclic movement. And languages do seem to have some ways of kind of marking the place where successive cyclic movement took place. And there are various ones. It may be that this falls in with them. There's interesting work on this. There's a Vietnamese student at MIT who published a paper couple of months ago in Theoretical Linguistics, where he basically argues that you can get a small piece, like, you know, a verb out of a verb phrase, copied if it's at the end of a prosodic unit, but not if it's in the middle of a prosodic unit. So you get different cases. SVO and SOV languages turn out, you know, in his analysis, to be different. The V can be left in an SOV language because it's the end of a prosodic phrase, but not in an SVO language. And I think, you know, there are interesting topics, and they're certainly worth pursuing, but they don't change the overwhelming fact that you don't pronounce the copies. I mean, maybe you pronounce little pieces of them here and there, but you never pronounce the full copy, and certainly not in complex cases where there's copies all over the place that are interpreted for reconstruction. So it seems like a very powerful principle with exceptions that are worth understanding.
I wonder whether agreement in 5 features is another way of creating discontinuous elements that get around this labeling problem for interpretation in the semantic. Have you heard all of that?
I'm not hearing. Yeah.
I'll start again. I wonder if agreement in 5 features in the syntax is another way of creating discontinuous elements that get around this problem of labeling and therefore interpretation in the semantics. And the motivation for the question, following on from 2 questions ago, is a study that David Adger and I recently published of Kiowa, which is a very free word order language. And after trying many different theories and different accounts within that theory, the only thing that we could get to work crucially involved leaving arguments in situ, that's to say where they're merged. But those arguments always undergo some form of phi agreement.
So wait a minute, if I understand, you interpret the arguments in situ, even though they're pronounced somewhere else?
No, you can leave arguments.
You can
leave arguments exactly where they're merged.
You can leave them.
Yeah, so they just don't
in
seem
their
to move at all.
external merged position, the sort of base position.
Yeah, that's right.
Okay, and what do you have outside?
You just get agreement in 5 features.
Oh, agreement features.
And so I'm wondering whether that will create a discontinuous element.
Well, yeah, I mean, then the question is, how do the agreement features get outside? You know, do they get internally merged? I mean, what does he propose?
Well, we just proposed the copying.
Copying.
Yeah, copying of the feature. So you've got an uninterpretable feature up higher that
so
needs
you
some
copy
kind of
the features to a higher position.
Yeah.
Yeah, which would be kind of the opposite of the polysynthetic languages, where you raise the arguments but you leave the features.
Well, we were actually arguing against the classic analysis of polysynthetic languages.
So you want to argue against the polysynthetic too. So you just raise the features in all the cases.
Yeah, if you want to think of it as raising, you could.
Well, is there another alternative description?
If you believe in unvalued features, that can be that
unvalued
copy
features,
the values.
Unvalued features externally merged.
Unvalued features externally merged that copy the lower features.
And how do they link up to the original externally merged arguments?
Presumably via some kind of search. So the kind of minimal search you were talking about would be fine.
But the search would have to be by the unvalued features.
That's right.
Yeah, that's okay, because that's the way it normally works. Mm-hmm. Search is by unvalued features.
And does that then create the kind of discontinuous element does that then create the kind of discontinuous element you were talking about that gets around this?
Well, it's not a discontinuous element, actually. It's that's actually agreement. It's like a long-distance agreement in, say, unaccusatives, isn't it? Where you have a higher feature and it searches for something and it gets its value from the thing it finds, like, arrived a man or something.
Yeah, but the thing is, this seems to allow you to get around moving the thing that
well, it
from
doesn't
its
get
base
around
position.
it. It's just any more than you get around moving the thing if you have long-distance agreement. It just doesn't take place.
Right, but weren't you saying that you have to move these things, otherwise you can't interpret them?
I don't follow that. I mean, this, from what you're describing, in fact, what I've seen, it looks just like long-distance agreement. There's no getting around internal merge. It just didn't take place.
Okay, I think I'll leave it there then.
Hmm?
I'll just leave it there. Maybe there's something I didn't understand, but it seemed
Yeah.
that you were saying that something was a problem that maybe isn't.
No, I don't think there's anything wrong with that. It looks like long-distance agreement in, say, Indo-European.
On a much more elementary level, Dr. Chomsky, what do you think is the significance of the single hyoid bone that was found attributable to Neanderthal?
The single, I'm sorry.
I believe there's only ever been a single hyoid bone.
There's never been a, I couldn't hear the word.
The hyoid bone? The hyoid bone is an anatomical structure that is essential to human speech.
Oh, the hyoid bone.
Right, yeah.
Yeah, okay.
So one has been found, and it was attributable to Neanderthal.
Yeah.
Does that mean he had language?
I don't think it means anything, frankly. That's Phil Lieberman's work, trying to tie evolution of language to the position of a certain bone, the hyoid bone. First of all, if it's true, it would have to do with externalization of language, with the use of the sensory motor system for perception and articulation. But we have good reason to believe that that's not an essential part of language. So, for example, sign language works just as well. The bones, first of all, their position differs in, say, children and adults, or for that matter, men and women. But that doesn't seem to affect anything about language. And furthermore, that same property has been found in many other organisms. Tecumseh Fitch published articles in which he's found it in deer and other things. I mean, there's a kind of Lieberman noticed a kind of a paradox. There is a shift in the laryngeal structure in humans, which is good for articulation. It helps articulation, but it's harmful for survival because it allows you to, if you're chewing food, it can go down the wrong channel. You can end up in your lungs, So it's kind of bad for survival, but marginally, very marginally, but good for articulation. And he argued that that's a factor in evolution of language. In fact, he says the factor. If it's true, then it's got to be pretty marginal, because for the reasons I mentioned. It hasn't been found in Neanderthal, but there's no reason to assume they had language.
I was wondering to what extent the I language you mentioned in your introduction can be construed as idiosyncratic language, also an I language, and at least partly so.
I'm sorry, I didn't understand. Anybody here?
Yes, I repeat. To what extent the I language...
The I language?
The I language, internal, that you mentioned in your introduction, can be construed, can be interpreted...
Can be interpreted?
As idiosyncratic language, which is another form of internal.
Somebody seems to hear...
It's a question of...
idiosyncratic.
Yeah, idiosyncratic language.
Yeah, I understand.
Or, in any case, partly so.
Yeah.
Partly so.
Well, it's a very interesting question.
Yeah.
The question is, to what extent is there variation in internal language? We know there's a huge amount of variation, at least superficially, in externalization. Okay, that's why we don't automatically understand some of the language. The question is whether that superficial differences reflects differences in the internal language.
Yes. Yes.
That's a research question.
Yes. Has it been recently investigated?
What do I think?
Yes. If it has been.
Yeah, it's
actually.
In fact, look, throughout the whole history of the subject, it's been assumed that the internal language varies all over the place. But the more that's been discovered, the less that appears to be true. So for a long time, some of the really most outstanding linguists, people like Ken Hale, believed that there was an internal parametric difference between sort of flat-structured languages, sort of free word order languages, and more hierarchically structured ones, with Japanese and German, and Walbury was the famous example, being taken to be examples of flat structure languages, free order. But the more that it's been investigated, the less that seems likely. I mean, in every one of the languages, including even Walbury, which was kind of like the extreme case, there does seem to be subtle evidence of hierarchic structure and even internal merge. So that difference seems to have been at least put into question, maybe leveled, and the same question arises about everything else. I mean, take what I mentioned, linearization. Is that in the syntax? If it's in the syntax, then yes, I languages are idiosyncratic in that respect. But is it in the syntax? Well, if it is, it's conceptually odd because it doesn't seem to enter the semantics, and it is strongly motivated by the sensory motor system. So we have to ask. And the same is true of many other issues, like take what he was mentioning about high particles searchsearching for arguments. Well, is that an I language difference? Or is it just a different mode of realization of the same I language? Those are serious research questions. And they're all over the place.
Yes. In an earlier place, you contrasted computation and communication, saying that this movement, the complexity was measured hierarchical rather than linear. That was good for computation, but bad for communication. But isn't it reasonable to think that we have the same computational needs in communication and in semantic interpretation, that we have need to minimize the computational complexity in semantic interpretation for the sake of efficiency of communication? And in fact, there has been some work done on that recently, which suggests that if you want to select the least complex among the possible recursive semantic interpretation functions, you will end up with those that are compositional, somewhat simplified.
Useful for conversation.
Sorry?
That are computational, that are
if you minimize time complexity of computing.
Then you get more communicative efficiency.
Yeah.
There may be such cases, but the interesting cases, I think, are the cases where they conflict, where computational efficiency and communicative efficiency conflict. Those are the revealing cases. I mean, the cases where they coincide don't tell you much, because they are consistent with the idea that the only thing that's happening is computational efficiency. They're consistent with that. And they would say, well, sometimes it works for communicative efficiency too. The interesting cases are where you get a conflict and ask how it's resolved. Okay. Is it resolved in favor of computational or communicative efficiency? And every case I know is resolved in favor of computational efficiency, and in fact, massively, like in the cases I mentioned. So I don't think the cases of convergence are interesting, but they don't really tell you much.
Well, I mean, once we have fixed the syntax, there is an additional question of what the semantics will look like. So there is neither then necessarily conflict or convergence, but a separate question. And there it seems that considerations of computational complexity play a role too. We get intuitively right result by applying considerations of complexity.
I don't understand. So these are cases of where you get computational efficiency and they give you the right semantics?
They give you the kind of semantics that you have reason.
That is useful for communication.
That's useful for communication, and that you have reason that is intuitively right. The compositional ones.
No, those are cases of convergence. It's a little hard to raise the questions about formal semantics because there has been no effort in formal semantics, plausibly, to try to find simple systems. I mean, just postulate anything you need.
I in fact, have done some work on that. I have done some work on that. So
you have done some work?
Yes.
Yeah, okay. Well, that would be interesting. But then we would search also to see, do we find cases of conflict? If we find that pure computational efficiency is yielding syntactic and semantic structures which are good for use, that's fine. But it doesn't tell us that communicative efficiency played any role in the evolution of language. It just tells us, well, you know, the simplest system worked out.
Good. Thank you.
Yes, I was wondering if you think we've been looking since the 50s about relation between works in biology and works in linguistics, biology of language. I was wondering to which extent today we can expect some works about physics of language and to which would lead, in fact, to unification of science. What can you say about that?
Well, there's one level at which there is interaction, and that's neurolinguistics. So it's possible now to carry out non-invasive studies of brain activity and try to ask what's happening when language is used. And some of that is quite interesting. I mean, for example, there's some evidence for that in creating artificial languages, here Andrea Moro's and the work of his group has been involved in this, in creating artificial languages, if you construct them in a way which violates linguistic principles, what we take to be linguistic principles, like no use of linear order, you get different brain activity, you know, not in the usual language centers than if you make up an artificial language which satisfies those conditions. So that there's quite interesting work by particularly Laura Ann Petito, who has found surprisingly that that signers, infants who grew up signing, you know, it's their language, and those who use spoken language, that the same brain areas are involved in analysis of what's coming in, which was kind of surprising because it was assumed for a long time that sign language would be more right hemisphere oriented because it's using vision. But it turns out that it's apparently using the same left hemisphere analytic areas that are used in spoken language. There was evidence to that effect from aphasia, Ursula Blugi and others found, but this is direct evidence from use of language, and she now has ways of getting information from very young children, a couple of days old, as to what's going on. She's also found things related to work originally by Jacques Meller and his lab, who showed surprisingly that very young infants, about as young as you can test, were able to distinguish their mother's language from another language, both spoken by a bilingual woman, a voice they'd never heard. And since then, there's been a lot of investigation to find out how languages parcel out among those distinctions. And it seems to be mostly prosody. Laura Ann's work, which is, I don't think it's even yet published, so I don't know how well accepted it is in the field, but she seems to have found a particular rhythm, which is about I think it's about 1 hertz or something. It's about the length of 2 syllables, a particular rhythm that excites the language areas even before birth, as early as you can test, which looks as though you could argue it's kind of geared to the eventual syllabic structure of all languages. It's in that range. And that's interesting. But about the more general question that you're asking, I really think it's far off. We don't know. I mean, if it were to turn out, what's called sometimes the strong minimalist thesis, that means the thesis that UG might just reduce to merge, period, maybe set and pair merge, and everything else is computationally efficient. I mean, if anything like that turned out to be true, which would be a pretty spectacular conclusion, then you might ask whether these same principles of computational efficiency show up elsewhere in the biological world. Like, do they show? I mean, there is a lot of optimization that goes on in biology, like the use of polyhedra to construct nests and so on. I mean, it is the most efficient mode of construction. Or phyllotaxis, the appearance of the Fibonacci series all over the place. I mean, that's now more or less explained on pure physical grounds. There are optimal foraging strategies that are used by animal, birds and insects and so on. There's apparently in very elementary organisms like nematodes, tiny little worm-like things. Chris Cherniak has argued that they get optimal neural wiring. Best, shortest possible wiring is what you get. And he suggests that the same is true for more complex systems. So there are cases of optimization all over the place. And the question is, can you find any unified theory of them? I think that's still pretty remote. And the case of language is a difficult one to assimilate to any of this because it's digital. Everything else is continuous. Well, neural wiring, I guess, is digital, but there's just no clear cases of digital structures like language.
Sure. Okay, I am interested in the small clause, which works with subject and predicate instead of subject and object. And I would like to know, how does that work? Do we still have to raise the subject and predicate?
Well, according to Morrow, you do. His work on copular structures does argue pretty convincingly, I think, that either the subject or the predicate raises and you get different interpretations. Does that generalize to small clauses more generally?
We don't know.
We need a better theory of small clauses to answer that. First of all, to find out which are the small clauses. Like a lot of people argue, they aren't really small clauses. They have an inflectional element of some sort that gives them a... those are, look, it's a good open question, but anywhere you pick, there are plenty of open questions like that.
Okay, thank you.
In a book in 1998 or 9, Lightfoot was talking about the question of the bilingual subject. And he said, Lightfoot, John Lightfoot, bilingual subject. And
bilingual subject.
Yeah, and he said we don't understand how it works yet. And
you mean an individual who's bilingual?
Yeah, a man speaking two or more. A person speaking two languages, yes. Mm-hmm. And he said, we don't have the solution yet. Let us allow us some time, and we make progress on UG, and we will come back with the solution. And he added, nothing makes us think that the creator did things so simple as to make our task easy. So have we progressed on that? And I haven't been aware of any further results in the meantime. Have we progressed on that?
Well, it's first of all, it's kind of a hard topic in which to sharpen the questions, because every person, except on the most unusual circumstances, is multilingual. I mean, we all grow up in a complex environment with well, we call them different dialects or something like that, but if the various languages we're acquiring are different enough, we call it multilingual. But it's not so clear that there's a critical difference between growing up where your aunt talks one way and your mother talks a different way and your kids in the street talk a little differently, which is the way we all grow up, and the case where the differences between them are what, from the outside, we call different languages. And picking up many different languages, really different, mutually unintelligible, that's pretty common in most parts of the world. Like in West Africa, apparently kids grow up speaking, 5 languages. And it's kind of an interesting phenomenon. I don't think, as far as I know, it hasn't been very well studied, but my oldest friend and closest colleague, Mars Halley, grew up in Latvia. And he grew up speaking 5 languages natively. He told me once that until he was about 4 years old, he didn't realize he was speaking different languages. It was kind of like an aha or Leibniz. All of a sudden, it kind of occurred to him, this is the way you talk to your teacher, this is the way you talk to your mother, this is the way you talk to the kids. But and we all do that at some level. And when the languages are mutually unintelligible, we call it multilingual. And there's no known limit, as far as I'm aware, on how many languages a child can pick up without any interference, just natively.
Okay, thank you. It's finished.